Welcome to my channel, and I'm back with you once again with another video of Microsoft Flight Simulator. Nowadays I'm exploring the Boeing 787-10, which is the default plane for the Microsoft Flight Simulator, and in this regard I'm doing a series of videos. So far I've uploaded 3 or 4 videos in which I have actually tried to break down all the aspects of flight for this plane. I've told you how to configure the CDU, how to fly the plane on autopilot, descent management and landing. But in this video I will cover all the aspects of flight for this plane, and it's going to be a complete tutorial, especially for the beginners, because whenever I make videos for the beginners. So I will just try to keep things very basic. So if you have a certain level of expertise and if you're watching this video, and then thank you very much for staying with me, and hopefully I will also try to learn something from you. If you've got anything to add to this video, the comment section is there for you. Today I will do a short flight from Riyadh to Abu Dhabi. This is actually a first flight that I ever took with the Boeing 787. I think it was -9, 5, 6, or maybe I think more than that years back, and it was a very nice flight. The cabin was really quiet, and I enjoyed that flight with Etihad Airways. So today I'm using the Etihad Airways livery, as you can see, and I'm parked at the King Khalid International Airport, and the ICAO code for this airport is OERK. So this is the plane. Before I start, let's have a look at different parts of the cockpit, because you have to be really familiar with the cockpit, because this is the place where you will be flying the plane. This is known as the overhead panel, and in this video I will just tell you what is the function performed by different controls over here on the overhead panel, because if you're a beginner and if you look at it, it's really overwhelming. These are the heads-up display for the captain and for the co-pilot. This is known as the glare shield, this whole part. It has actually 2 parts, this on the left side and on the right side. This is known as the EFIS, which is the Electronic Flight Instrument System. This is the MCP, which is the Mode Control Panel. And then you have got 2 displays over here on the captain side and 2 displays over here on the co-pilot side. This is the primary flight display, and this is the navigation display, plus you can also have a system information on it, CDU, as you can see it over here. So I will also tell you how to interact with these screens. This is the pedestal, and over here you will see another big screen which has got 2 parts, and you can see the CDU, which is a control and display unit. So with the help of the control and display unit, you actually interact with the flight management system, and you give all the inputs regarding the flight over here. This is the throttle, this is the lever for the flaps, this is the lever for the speed brakes, this is the parking brake, and then we have radio communication panel over here. We will not be interacting with it, but if later on if I'll make a video for the VATSIM, then definitely I will cover this part. So this was a short introduction of the plane. So first of all, let's start the plane from the cold and dark state, and let's try to get some power in the plane so that we can interact with the systems. So first of all, you have to turn on the batteries. If you go over here on the overhead panel, in the electrical side, you will see this button, battery. So once you have turned on the battery, you will see some life coming into the plane. Great. Now you can see the navigation display is up, and with the navigation display, the ICAS is also up. ICAS is also known as the engine indicating and crew alerting system. Over here on the ICAS display, you will see information related to the engines, and plus if there is any error, it will appear over here. As you can see that multiple errors are coming over here, but as soon as we'll proceed through the startup procedures, these errors will start to disappear. So once you have the battery, all you have to check is that the parking brake is set. This is the most important thing. Okay, then the primary hydraulic pumps are on. So if you go over here on the overhead panel, if I press Control 8, I will take you to the overhead panel. So over here you will see the hydraulic panel. It has got 3 different pumps: primary, C1 and C2 electrical, and demand electric. So at this point, the primary pumps should be on, but the C1, C2 electric pumps and the demand electric pumps left and right, they should be off. Then what you have to do is this: you have to check whether the wipers are off or on. So this is the control for the wipers for the left and for the right hand side. They should be off. And then if I press Control 8, go back to the previous view, just make sure that the gear lever is down, and plus throttle is also in the idle position over here. And just also make sure if you're using any controller, obviously you will be using any controller. So if you've got some throttle settings on it, it's also in idle position, because if you just don't leave your controller throttle in the idle position, then obviously there will be a problem. So just make sure it's in the idle position. Stab trim switches are guarded, although we cannot interact with it, but just for the startup procedures, just have a look at it. Fuel control switches are cut off. So these two switches are for the fuel control for the engine. They should be cut off once we start them, the engines, and then we will move them to the run position. Alternate flap selector is off. So if I move here, let me just show you. Over here, you will see alternate flap selector. It should be covered. It's actually used when you have some hydraulic failure and you want to use electrical systems for the flaps. Then you use this option. Otherwise, we will not be using this option in this flight. Now, that's it. Now, we cannot run this plane on the battery for a long time, because obviously the battery will run out of power. So we have to actually connect the plane to the external power. So if you go over here on the overhead panel and in the electrical side, you will see forward external power and left and right, and then aft external power. So you only turn on the forward external power left and right, because it's used for all the ground services till the time you have started your engines or you start your APU. The power will be coming from the external power source. For aft external power, it's only used for the maintenance purpose. That's it. Now you have some power in the plane. Once you turn on the external power, you can see the primary flight display is up and all the screens are up and running now. There is power in the plane. Now, what you have to do is this. First of all, you have to get the IRS alignment of the plane. So if you go over here on the overhead panel, let me just show you. I press Control 8. You will see these two knobs. This is IRS, which is Inertial Reference System. It's actually a system which gives the GPS coordinates to the plane. So if it's off, your plane or the CDU or the flight management system will never know the position of the plane. So in order to get the GPS coordinates, you have to turn on the IRS. So just click them and turn them on. That's it. So now we have the external power coming in. IRS is active. Now it's time to interact with the CDU, which is the control and display unit. So let's go over here. Control 3, and you will have this view. Now, first of all, you will see this page ident, which will give you the model of the plane, plus the engine, Trent 1000, and the ARAC cycle. ARAC cycle is actually a database which has the information of all the A-ways, the waypoints, and the A-ports. It should be updated. And the best part about Microsoft Flight Simulators is that the ARAC cycle is always updated for the planes. Now, what you have to do is this. You have to go to Index, and you will see all the options to configure the CDU. And we will go in this sequence. First of all, we'd set the position, then performance, thrust limit, takeoff, and approach. But before this, we have to go to settings and do a few things. Over here, you will see IRS align time. Instant, accelerated, or real. If you set it to real, the plane will take 7 to 8 minutes to get the IRS alignment. And if you use accelerated, maybe 2 to 3 minutes, but I'm always using instant. If you want to change it, you can always click this option and it will be changed. But right now, as I've already done the IRS alignment, so that's why even if I change it, there will be no impact. But on the next flight, you will feel or you will see the difference. Then another thing you have to do is this, that you have to connect the CDU with the Simbrief account. And it's important to do that because, you can now import flight plans from the Simbrief in this plane. if you don't know about Simbrief, I would just like to tell you that it's a free resource available on the internet, and you can make flight plans with that. So in order to connect the CDU with the Simbrief, go to this option, next page. As you can see over here, this is coming as 1/2. So anytime in the CDU, if you see a page like this, which has got multiple pages, so you can always scroll through them by using previous page and next page. So over here, I can enter the user ID and the username. So far, I have entered the user ID of my Simbrief. So if you go to the Simbrief and you make your free account, you can get the user ID from there, or the pilot ID, and you can enter this information over here. As you can see, the pilot ID will be here in this box. So all you have to do is this: enter the pilot ID by using the scratch pad, and then it will be entered. That's it. This is first thing that you have to do. Another thing, you have to get the weight and balance information from the operational flight plan, or the OFP. So now I have to make a flight plan in the Simbrief in order to get all the payload and fuel calculations and the passenger count from the flight plan. So let's go to Simbrief and make a flight plan, and then just come here and continue with the configuration. So this is the interface for the Simbrief, and you can just enter some information over here, and the flight plan will be generated for you. For the departure airport, I will be using OERK. You always use the account codes for the airport. So if you don't know any the account code for the airport, you can always Google it, or you can just search for the airport in Microsoft Flight Simulator, and you'll get the account code. And for the Abu Dhabi International Airport, it is OMAA. Then you have to select the aircraft type. I will be flying the Boeing 787-10, so you can just scroll through it, and then you can select the Boeing 787-10. The variant of the airframe is working title 787-10, so you have to select this option, because then you will get the right calculation for the plane. Cost index. Now, it's a number which actually determines how much fuel will be burned during the flight. The lower the number, the less fuel will be burned. The plane will obviously fly at a lower speed, but its range will increase. So if you're doing a long flights, you should enter a small number. But if you want the plane to go at a higher speed, then you select a higher number. It can be between 0 and 100. I always use 100 for the Boeing 787-10. It actually goes at a very high speed, but it burns more fuel. That's it. Now you have to select the runways. The departure runway will be 33 right. As I've previously used these runways for my video, so in order to have a consistency, I'm selecting these runways. And for the Abu Dhabi International Airport, I will be using 31 left. That's it. Altitude will be 38,000 feet. That's it. And I will be carrying full passengers. Now, you have a fully functional flight plan. All you have to do is this: generate the flight. But before this, I would just like to take you to this flight plan over here, which is coming. And I want to just explain a few things to you, just for your understanding. Over here, you will seeing different options coming. You can always change the flight plan. You can have different sit and stop, and you can have different waypoints. But I always go with the one that's showing right now. So this flight plan has got actually 4 parts. SID, which is the standard instrument departure. STAR, which is the standard terminal arrival, and the waypoints and the airways. Now, the start of the flight plan has a SID, which is a standard instrument departure. It's actually a procedure to fly out of an airport. You don't simply fly out of an airport. There is also a procedure which tells you the speed, the altitude, and if there are any constraints, they are determined by the SID. And then you have STAR, which is the standard terminal arrival. So if you look over here, it's not even appearing very clear for the Abu Dhabi International Airport. But if you look at the Dubai International Airport, because it's an alternate airport for this flight, you will see there's a procedure. You go here, and then you land. So standard terminal arrival is also a procedure to land at an airport, which tells you different constraints. So the set and star has to be entered in the flight plan, and I will just tell you how to do that. So once you have the flight plan, all you have to do is this: generate the flight. And then you have the flight plan. You have the empty weight of the plane, the estimated zero fuel weight. So everything is coming over here. Now, if I click View PDF, you will see the operational flight plan. All you have to do is this, as a beginner, have a look at this number. This is the zero fuel weight, the plane weight without the fuel. And if you add the fuel, the total fuel is coming over here. The block fuel is 13 tons or 13,212 kgs. This is the reserve. We will be using it for the flight planning, 5 tons or 5,095 kilograms. This is the flight plan, the runway for the takeoff, which is 33 right. And then you have the standard instrument departure, ALTAV 1K. And then you have the standard terminal arrival, and plus you have the runway for the landing. Now in between, these are all waypoints and airways. It's very simple to determine an airway and a waypoint. Anything coming in alpha value is a waypoint, and anything coming as an alphanumeric value is your airway, L604 and 685. That's it. And the last thing that you want to refer to in the operational flight plan is the airport weather list. So if you go to this page 10, you will see the weather list. This is the weather coming for the departure. Only this line you have to consider. And for the destination, it's coming. That's it. So if you are a beginner and you want to know how to read the operational flight plan, there's also guidance on the Simbrief. You can always go and refer to those, you can say, explanations of all the parts of an operational flight plan. But for this operational flight plan, I'm just trying to keep things simple so that you can easily fly the plane and you can make a flight plan. So once you have the operational flight plan, simply set from operational flight plan or OFP, and then you can see the zero fuel weight 172 tons or 172,155 kilograms. So if you can see, it's matching the operational flight plan from the Simbrief. Then you have center of gravity coming, because you have to adjust the center of gravity. Now the cargo is 9 tons, passenger 344 as we have selected, and the fuel is 13,212 kgs. As you can see, the fuel quantity, it's coming 6.6 and 6.6 in the left and in the right wings, nothing in the center tanks. So this is actually set. If you're doing a long flight, then obviously you will have fuel over here in the center tanks also. So you can see the fuel is now there in the plane and it's adjusted. The gross weight is coming 185 tons. And that's it. Just keep in mind that the center of gravity for this plane right now for this flight is 31.38. In this video, I'm just refraining from using the Navigraph because, for the Navigraph charts, you should have a subscription. Obviously, even for the Simbrief, you should have a subscription for the air rack cycle. Just to tell you one thing, which I really forgot. So if I go here in the Simbrief, and if I go back to this option, let me just bring it for the full screen, and if I edit the flight, you can see the current air rack cycle is updated. So if you're using Simbrief for the flight planning, you should have an Navigraph subscription. It's good to have that because then you will have a good flight plan. But still, if you don't have, you can try your luck, or you can use any other flight planning tool. But I prefer to use Simbrief with Navigraph because I have always the updated air rack cycles. So if you don't have a subscription, you will see that your air rack cycle will not be updated over here. So coming back to the plane, simply press return and go to index. Now we have done some preliminary pre-flight procedures. Now it's time for the pre-flight procedures. So first of all, go to this option, position, and enter the airport at which you are parked right now, which is OERK. That's it. So you have your reference airport. Now you can see the GPS coordinates are coming because we have the IRS on. Then go to this option, route, and then simply request the route. It will be actually updated from the operational flight plan. It will just take some time, 3-4 seconds, maybe 5 seconds. And once you have the information from the operational flight plan, you will see this message. As you can see, this message is coming over here. So as soon as you load it, this will disappear. So now the operational flight plan is there in the CDU, which is the control and display unit. Now I have to select the departure runway, which is 33 right. And that's it. Now you can press execute. Remember this thing, that in order to have the flight plan in the plane, you have to generate the flight plan at the Simbrief, as I've done it previously. If you don't generate the flight plan, if you don't click that button, generate flight plan, in the Simbrief, you will not have a flight plan coming over here. So whatever you have created previously, it will be imported. So just make sure that you generate the flight plan once you have entered all the values required for the flight planning. Now for the departure, you have to select the SID. As I've told you before, it's actually a procedure to fly out of an airport. So if you look at the navigation display, and if I just zoom out, I'll just try to do it from here. So if I just zoom out, you will see that there is a straight line going from this airport because I haven't selected any departure procedure. So you have to select that. If you go to the flight plan, and as I've shown you before, that ALTAV1K is the SID. So you will see it coming over here because the characters are short over here, so that's why it omits few letters, but you have to find the one that actually looks like that. So select ALT1K and press execute. Now you have a proper departure procedure coming, and now for the arrival, you have to select the arrival. It's 31 left, so let's select IRS 31 left, and the star is UKILI 3D, as you can see it over here. So UKILI 3D. Let's select this one. Now the major challenge comes. This is actually a transition. You have to select the transition, ITRIN or PGAM. Now over here, I have actually two tricks to tell you as a beginner. You can select any of them, and then you can make a flight plan and see whether you have selected the right transition or not, or you can refer to the airport charts. So I will tell you both the procedures. So if you go to this option plan over here in the navigation display, you will be able to see the flight plan. Just zoom out a bit. First of all, select any of the transitions. For some airports, it can be 5 or 6 transitions, but for this airport, it's coming 2, so it's easy to select. But now I will tell you how to select this one and how to read it from the Navigraph charts. So select ITRIN. Let's say you don't know which transition to select. Now go to this option legs. It will show you all the waypoints and the airways for this flight and all the constraints. And press this button step. So you will see on the navigation display that you're stepping through the flight plan to see whether there is any issue in the flight plan or not. Okay. So now you can see there is a discontinuity coming. It is actually a discontinuity because this is not as per the actual flight plan. In this regard, what happens is this, that you get the vectors. Once you reach this point, tap to, you get vectors for ITRIN, and then you go for the approach, finals, and then landing. But if you don't want to use the options vector, because if you're using vectors, then you have to disengage the autopilot, the VNAV option, or the LNAV option, and then you have to fly the plane on heading mode. But in this flight, as I'm assuming that the beginners will be watching it, so I will not recommend doing this, flying in the heading mode. If with some expertise you can do that, maybe I'll also make a video in the future for this. But right now what you can do is this. You can delete this option vectors, and you can connect this line, so you'll go straight to ITREN. So let's press Control 3 and have a good view of the CDU. Delete and delete. And then you will also see another discontinuity coming, because this is a discontinuity. So you have to get rid of it as well. Press delete and then delete and press execute. Now you will see that the line from TAPTO is connected to AA430. Although ITREN is also coming, obviously it will go over here. So this is a good flight plan. What if I have selected PGM? And let's see what happens. So if I select PGM, what will happen? So PGM is, you can see, slightly diverted over here. And if I go over here and if I select, I hope it happens, because it usually happens when I'm flying alone. I can show you this example. Delete, vectors, delete, and execute. So if I go to the next page, you can see now it's coming as Lubick, and before this there is this option coming as PGM. Okay. So let's zoom out a bit and let's see. So you can see the PGM is also coming, and it's part of the flight plan. In some cases, I have actually seen a discontinuity in the line as well after adjusting this. But anyhow, in this instance, I am also getting PGM as part of the flight plan. So you can go back, and then you can go to departure, and you can select the transition based on the Navigraph charts. Airport charts are really important for the flying, so you should have a subscription of the Navigraph charts, or you try to find out these charts on the internet, because it makes really interactive the whole flight experience. So if I come over here and if I unload this flight plan, import from flight, like this. Now, ILS 31 left is the runway that I will be using for the landing. So what I can do is this: for the Abu Dhabi International Airport, I can go to these charts, approach, 31 left, and I can use category 2, 3 ILS runway. I can also pin it over here. So now it's pinned, and then I can have a look at it. Oops. Now, as you can see, these 2 points are coming, ITREN and PGM. So if you're coming or from this side of the runway, then you will be using PGM as the transition. Yes, exactly. And if you're coming from this side, you will be using ITREN. So in this flight plan, as I'm coming from this side, so I'll be using ITREN. So I will use ITREN. Unfortunately, in Simbrief, you don't get the transitions. Maybe in the future, you also start seeing the transitions. But for this, you have to use the airport charts, or the method that I told you, that just use it, any transition you want, and see whether your flight plan makes sense or not. And if it doesn't, you can always come and change it back. So now I can go to legs, and I can delete this discontinuity over here. It says vector. So let me get rid of the yoke, and then I can delete it. Because this is one of the most tricky parts, and as a beginner, I have been struggling a lot with this, so that's why I have spent some time in explaining this thing. So now you have the flight plan, and now you have to continue with the rest of the configuration of the CDU. So now you have the plan, init ref, press this button, and you can always press index, go back, but right now you have to press this button, init ref, and fill in the information over here. This is actually, init ref is initial reference, 0 fuel weight, you have to enter. Simply click this button, adjacent to 0 fuel weight. You will see it coming over here, press it again, and it will be entered. Reserves, this is 5 tons as we have seen it before in the operational flight plan. If I go back to the flight plan, I will show it to you over here. Final reserves and alternate 5 tons. Remember this thing that on the CDU page, any page, if you see boxes like this, remember this information has to be entered. This is necessary. This is important. Now the cost index is 100. So you press this and that's it. Now go to the thrust limit. What are these thrust limits? This is actually assumed temperature takeoff method. What you do is this, you calculate the takeoff performance in order to put less stress on the engines. You have thrust settings coming for the takeoff and for the climb. You can have a reduced thrust. Let's say over here, it's reduced to 10%, it's reduced to 20%. Or you can have a maximum thrust. And with the climb also, you can have a full thrust climb, reduced thrust climb. Climb, I always use this option, the first option. And for the takeoff thrust, you have to actually use the electronic flight bag in this plane, if I can show you over here. This was actually not previously available in the Boeing 787-10 versions, but now it's available. You can calculate the takeoff performance. So press this button, take off. So just leave this page like this. Don't change any options over here. But if you want to, have reduced thrust for the climb, then you can use these options. Otherwise, I always use this one. And this one will be automatically selected by the electronic flight bag. Now go to the takeoff. And for this page, let's now go to the electronic flight bag and get the takeoff performance calculation. But before this, you have to get the QNH, the atmospheric pressure. So let's go to the weather in the operational flight plan and see what's the QNH of King Khalid International Airport right now. Just scroll down to page 10, where you will see the airport weather list. Now this is important. This line. This is for the Riyadh or the King Khalid International Airport. The QNH right now in Riyadh is 1009. So just go back and you have to adjust the barometric pressure, because the plane actually uses the barometric pressure to gauge the altitude of the plane. And for this, you have to actually adjust the altimeter so that you get the right readings. You change the units by going over here in the EFS part, EFS, which is Electronic Flight Instrument System. Just press this option and move it to HPA. You will see it's coming. 1009. That's it. Now you have adjusted the barometric pressure because it's required for the takeoff performance calculation. So go over here. Now in the electronic flight bag, you first of all press this option, initialize flight, then click this option, performance, and then you will have this page. Copy FMC data, any information that was there in the FMC, it will be copied over here. You can see the airport is coming, the runway is coming 33 right, and plus the condition is right now dry. Let's get the wind. So for the wind, you can see it's coming as from 110 degrees, 10 knots. So this is the wind right now at the airport, 110/10, 110/10. You can see it's coming over here now, entered. The temperature, you will get it from here, maximum 28, minimum 9. So as I'm flying in the morning, so right now the temperature is 22, 23. You can always enter 28 as well. Because if you're entering a higher temperature, then the assumed temperature method used for the calculation of the takeoff performance will actually see that it's very hot outside. So it will just try to give less stress to the engines, less power to the engines, but still your plane will take off. This will actually save the life of the plane, of the engines, not the plane. But obviously, engines are part of the plane. Anyhow, this is actually recording these videos is a very tiring procedure. It's a lengthy procedure. So at times, you just get lost. Okay, for the rating optimum, you can always select a reduced thrust. You can set the maximum takeoff if you want a reduced thrust or whatever. But right now I'm selecting the optimum option because then this calculator will actually get the optimum, what you can say, thrust for the engines for the takeoff. Flap configuration, also select optimum, let the system select it, otherwise you can always override it by giving the flaps that you want. Anti-ice configuration, let's set it to engine auto. And although I'm not flying in the icing condition, so I can always turn it off as well, but as I will be selecting the anti-ice to auto during the flight, so that's why I will select engine auto. And the center of gravity, as we have seen it before, in the weight and balance, is 31. So now all the information is entered. You can press calculate, and now ATM, assume temperature method. So now the system has actually selected a temperature that right now I've selected 28, but it has selected 49 degrees. So it's trying to trick the system, the flight management guidance system, that the temperature outside is very hot. It's 49 degrees. So reduce thrust. You can see different speeds coming: V1, VR, and V2. V1 is the speed at which you have to take off. Before this speed, you can just abort the takeoff, but after this speed, you have to go and take the plane up in the air, and then you can just always come back and land if there is any issue. VR is basically the speed at which you rotate. You just pull back on the yoke to take the plane up in the air. And V2 is the speed at which the plane can still fly if one engine fails. So right after the takeoff, you try to reach the speed. And once you have attained the speed, then if there is any issue with one of the engines, you can always come back and land. And you can see it's a deaccelerated takeoff, TO2, 56.3%. So only 56% power will be given to the engines. Flaps set to 5, runway 33 right, and takeoff gross weight is also coming. Now send this output to FMC, and let's go to the FMC. Now over here, you've seen the takeoff data uplink. It's coming, takeoff data ready to accept or reject on takeoff reference page. Just accept it, and you have all the information coming over here. 5 flaps, thrust reduced, 49 degrees centigrade is the temperature, reduced to thrust takeoff 2. Now you can see these 2 empty boxes coming, so this value has to be entered. So once you press this button and you go over here, you can see the center of gravity is coming, 31. Now as the FMC pre-flight procedures are complete, now I will just go out of this view, and then we have to carry on with the pre-flight procedures on the overhead panel. So press Control 8 and you will have the view of the overhead panel. Now first of all, we have to start from the top, and we go to the bottom, and from left to right. So we go like this, this, and this. Okay, so this is the procedure. Okay, so first of all, make sure that the flight control surfaces, they show normal and they're covered. Obviously you cannot interact with it, but just for the information purpose. Heading reference is set to normal. You have IRS alignment is on. Primary flight computers covered. And then you have the in-flight entertainment and the passenger seats, it's on. Otherwise you can turn it off. Obviously all the in-flight entertainment systems will be off. Cabin utility is on. And APU generator is also on. And the generator control switches are on, as you can see it over here. These are all on. And the drive disconnect, all the buttons, they say drive, although you cannot even interact with them, but they're covered. Then make sure that the Viper is also off. We have also seen it before as well, but just make sure that the Vipers are off. But if it's raining, then you can turn them on after the pushback, because then you need it. Then over here, this is the panel for the battery. You can test it. It's actually used for towing in order to see how much battery is left in the plane, although it's not required. Then I always call it the flight director door. I always say this is the flight deck door. Power, it's on. And CCR reset, which is the common computing resources, it is covered. Then you have emergency lights. Simply they're in the off position. Arm them and just cover. The service intercom is off, although you cannot even interact with it. Passenger oxygen, it's also covered and on. And then you have the window heat, and you can see the backup is already on. You cannot even interact with it, but the primary, just turn it on. the window heat, and then the RAM air turbine is covered. It's actually a turbine which is used in order to have electrical power in the plane if the engines fail and you cannot even turn on the APU. It's done during the flight. This turbine actually gives power to the plane, but you cannot interact with it right now. Now for the hydraulic panel, over here you will see, as I've told you before, the primary left and right should be on. Right now the C1, C2 electrical and the demand electric pumps left and right, they're in off position, but before the pushback I will turn them to auto, and once the engines are up and running, the plane will have the hydraulic systems up and running also. Then passenger seat, you can set it to auto, you can turn it on as the fueling is now done. If the fueling is getting done right now, then you cannot turn on the passenger signs. Otherwise, I set it to auto. What happens is this, that during the takeoff, after 10,000 feet, the seatbelt signs, they go off, and during the landing, below 10,000 feet, the passenger signs, they are on. But if you extend the flaps even at 30,000 feet or 35,000 feet or 30,000 feet, if you start extending the flaps, then the seatbelt signs will on. Now this is actually the brightness for the overhead panel. You can use it. Then there is a dome light. If it's night, then you can see, but you can see the dome light is on. Actually, in the night, you have to have an increased dome light so that the ground staff can see the pilots in the cockpit. And after the pushback, once you are ready to taxi and take off, then you turn off the dome light so that the pilots can see clearly. And obviously, after the pushback, there is no contact with the ground staff, so you don't need the dome light. Then you have master brightness. I have tried it. It doesn't work, but you can also try it at your own end. Now, this is the control for the glare shield. As I've told you before, this is the glare shield, this whole thing. And you can always, increase or decrease the brightness of the glare shield. The backlight's on and off. And plus, you have this light over here. You can always increase and decrease it. That's it. And now you have, you cannot actually interact with all these systems, the cargo, fire, dispatch, engine, EEC mode. You cannot even interact with it, which is the engine electronic control mode. So fuel jettison, nozzle, you can just interact with it, just make sure they're covered. Okay. And then just make sure that the fuel pumps are off right now, and the crossfeed is also off. And right now you can see press is coming on the 4 buttons on the left and the right pump, but the center pumps, nothing is coming because there's no fuel in the center pumps, but we have them in the right and the left pump. So once you start the pushback or before the pushback, you turn on the fuel pumps, and you only press these buttons where this option press is coming. Now anti-ice, set it to auto. That's it. And with this, you have to turn on the nav light. Just give you a little introduction of the nav light. So if I just step outside, and if I show you, there is a green light over here on the wingtip, as you can see. In the morning, obviously, if any other plane is looking at this plane, it will know that it's going towards the right side. But in the night, if it's too dark, and if any other plane is looking at this green light, so it means you're looking at the plane from its right side and it's going towards the right side. And then there is also another one on the left, so which is red. So if any plane is seeing a red light, it means the plane is going towards its left. And at the back, you have bright white lights. You cannot see them in the morning right now, but in the night, it makes more sense. So let's go here and turn on the nav lights because the nav lights are required. Now over here, the humid is on, although you cannot interact with it. The cargo temperature, you can set it, the cargo temperature. Then for the air conditioning, the equipment cooling, forward and aft, it's set to auto. Recirculation fans are on. Just make sure they're on. You can interact with them, all these 4 buttons. Just make sure these 2 show auto and these 2 show on. And then you can set the temperature for the flight deck and for the cabin. And then you have air conditioning packs now set to auto. Initially, if you were flying the Boeing 737, you will see that you turn on the packs, and before you start the engines, you turn off the packs. And once you have the engines, then you turn on the packs because This is the procedure in the Boeing 737. But in the Boeing 787, you set them to auto. Once you press them, it's auto. Once the engine is about to start, the packs go off. And once you have the engines, then the packs are on. That's it. And the pressurization, you cannot interact with. Just leave this part. You cannot interact with it, so no need to discuss this. And then you have the wipers bright. They're also off. Now, that's it. Now what you're going to do is this. You're going to get back to this view. And there are a few things that you have to do. On the EFIS, Electronic Flight Instrument System, just press this button, traffic. You will see these circles, the range for the navigation display. You will see this. And for the mode control panel over here, just turn on the flight director. And auto throttle, just arm it, because if it's not armed, then obviously whatever the speed is set by the autopilot, the plane will actually not follow that. And the auto brake is set to RTO, which is the rejected takeoff. As you can see it over here in the ICAS, it's also coming. So it's actually a braking system which is used in order to stop the plane before the V1. If you want to abort the takeoff. So V1 is 145 knots. So if before the speed you want to just abort the takeoff, then the auto brakes will help the plane to stop. That's it. And transponder mode, just make sure it's in the standby mode over here in the pedestal. You will see this communication port, or everything related to communication, and you will see transponder right now, it's standby. So as now the pre-flight procedures are complete, so now we can run the checklist for the pre-flight procedures. So go over here. Now these screens, you can interact with them. You can have the checklist over here, but just make sure that it's a comfortable view. Although after the flight, after all the startup procedure and everything is done, not after the flight, I will be using the checklist over here on the screen. But right now, for this, just to show you, you can change the view over here. You can have the checklist over here. You can have the CDU or the system. Let's see, if I bring up system, it's also over here. And if I bring up CDU, it's back again. And if I want the checklist, it will come over here. For the pre-flight, now the braking parks. This was a nice one. Parking brake is set, and fuel control switches are cut off. Press normal. Go to the next page. Passenger signs, as we have already set the seatbelt signs to auto. Mode control panel I have set. Okay, so no, I haven't set it. So what I'm going to do is this. I'm going to set all the information over here and go to this part. Now V2 is 152 knots. So just reduce the speed to 152 knots. So this is the speed which autopilot will actually 157. Yes, exactly. It's actually a speed, as I've told you before, the plane can still fly with one engine if there's any engine failure. So because of this auto throttle, and the flight management guidance system will actually try to achieve the speed soon after the takeoff. Now you have to set the heading of the runway from which you will be flying out. It's not necessary that you will be using LNAV and VNAV. Maybe you might turn it on later in the flight, but maybe you after the takeoff you want to fly in the heading mode. So this is what I will explain it to you. So what you have to do is this. You have to get the charts up again in order to see what's the heading of the runway from which I'm taking off. So if I open this airport chart, you will see the heading is 327. So just set this heading over here. Although I will not be using the heading mode, I will use LNAV and VNAV, but it's a procedure, 327 degrees. That's it. I can just minimize it and keep it here because I will be needing this during this flight. Okay, and the altitude to which I will be flying out will be 38,000 feet. I'll keep 38,000 feet over here, but I will just tell you one more thing about it. Okay, now what you have to do is this. You have to look at the SID. As I've told you before, SID is actually a standard instrument departure. So you have to look for any constraints during the departure. Although you will be using VNAV and LNAV, LNAV is actually Longitudinal navigation, VNAV is your vertical navigation, and this option tells the plane where to go, either left or right, and VNAV actually sets the speed and the climb and the descent rate of the plane. So as you will be using it, so it will be following all the constraints coming over here in navigation display, but just for the takeoff briefing, you have to look at it. So as soon as you take off, you will come to this point bottom. At this point, your altitude should be more than 2,900. And then at this point, 7,000, if I even click this option, you will see that which SID we are using. We're not going right, we're going straight. Now at this point, the flight level should not be more than, as you can see, this line is coming up. So it means there is a ceiling for 20,000. And over here, this line is coming at the bottom, so it means you should be above this altitude. Minimum 7,000 or more than that. And over here, maximum 20,000 or less than that. Now what I have to, I can also set 20,000 over here. If it's a step climb or if I'm getting information from the ATC for the different altitudes, then obviously I will be using, setting the altitude over here at 20,000. But as I've told you before, the VNAV actually will control the descent and the climb rate and plus the speed. So you don't really have to worry about it. You just have to see and you should know what are the procedures for the departure. And that's it. So nothing else? Okay. And you can see the speed is coming maximum 250 knots. So your speed should not be more than 250 knots at this point. LTAF, you can be less than 250 knots, but not be more than that. Okay, so that's it. So I've set it to 30,000 feet, and I will let the VNAV do all the calculations and follow all the constraints during the flight. So with this, I will turn the LNAV and VNAV also active. Now, as I've done all these things, just make sure all the doors are closed. I haven't done the ground services right now. As you can see, everything is disconnected, but just to make sure, just go over here on this display, press this option door in the system. As you can see, all the doors are closed, but they are manual. But once you have done the pushback, they will turn to auto. That's it. Let's go back to start and set demand electric pump to auto. Now go over here, and now it's time to have the hydraulic systems up and running. If I bring this thing up, I will show you hydraulics. So right now you can see they're all off. Nothing is working in the hydraulics. You have to turn on the hydraulic systems in order to have what you can say get the controls. Because right now, I think if I go to flight control and if I move the yoke, you will see nothing is happening because the hydraulic systems are off. So once the engines are on, then the hydraulic systems will be up and running. Okay. So let's go here and let's turn it to auto. Nothing will happen. Okay. So once the engines are up and running, then you will have hydraulic systems. That's it. Now, you have to also set the trim for the takeoff. It's actually based on the center of gravity of the plane. The trim is calculated whether during the takeoff the elevators will placed in such a way that the plane will pitch nose up or down during the takeoff. So it's nose down, 3.25 is the trim. You can adjust it by using these buttons on the yoke, as you can see. But you have to really wait for it. It will take a lot of time. I'm using the Thrustmaster TCA quadrant for Airbus, so I have the button over here. With this, I can set the trim 3.25. Okay. So now this is also done. Mode control panel is done. Takeoff speeds I've also entered. CDU pre-flight is complete. Taxi and takeoff briefing, we have done it. And now it's time to turn on the beacon. Beacon is actually a red light at the bottom and the top of the plane, which actually tells the ground staff that you are going to turn on the engines, as you can see it over here and at the bottom. So now the ground staff should actually clear everything from this area, because now the pushback will start and the plane will start its engines. That's it. Now you can see over here, before start, I've done all the things, and this checklist is good. So I can just get rid of it, and before taxi, not needed right now. I will be using it later. Now just press CD over here, and let's set transponder to XPDR. And now the real thing begins. We have to now turn on the APU in order to have power in the plane, because APU is auxiliary power unit. It's generated at the back of the plane, which actually gives power to the plane once you have to start the pushback, because once you will start the pushback, the external power unit will be disconnected from the plane. And if you have no power in the plane, then how you will start the engine? So you need APU for this. So I will start the APU. If you go up in the electrical part, you will see APU. You have to move it to start, and then it will automatically come back to on. That's it. Now you have to wait for it. APU, you can see the RPM coming, EGT, which is the exhaust gas temperature. The RPM should be 100, and once it stabilizes, you will see this external power. Right now it's on, but it will be automatically cut off once you have power coming in from the APU, and then it will say available. So wait for it to reach 100. Now you can see on the ICAS APU running, and the exhaust gas temperature will also stabilize. 382. Okay. Now you will see the external power is automatically off, and it says available. That's it. Now what you can do is this. You can call for the pushback and release the parking brake. So this is the parking brake. I can release it, and then I can call for the pushback. Go to the radio communication, ground. Actually, I have turned off the volumes for the ATC, because it's lots of disturbance during the flight. And now I can ask for the pushback. You can see the pushback tug is moving. Okay. Now, as you can see it over here on this display, that I have to go here. So the during the pushback, I will turn right. If I just bring it close, I will turn right, and then I will go this way. Okay. So everything is good now. Now with this, I will start turning on the engines because I want to save some time. So engine start switch, right engine on. So this is the engine start switch. Just move it to start. And then fuel control switch, turn it to run. And similarly, you do it for the engine 2, and then do it for the engine 1. Just move this to start, and then fuel cutoff, run. And now you will see on the ICAS that now both the engines are running. What you can do is this right now. You can also bring up the hydraulic panel, and you can see whether you have hydraulic systems up and running. You can see the pressure is increasing. Now this hydraulic system is up, and then this will also run. See? So now the flight controls will be available to you. You can bring this page up, and you can see right now all the options have disappeared, all the errors. Now you can turn right. I think I have missed. I always do this. Anyhow, it's a very short. What I can do is this. I can stop this pushback before I go into the ground, and I can just engage the parking brakes in order to stop. And that's it. I can get rid of the pushback. Is a bit boring in the Microsoft Flight Simulator. You should be using any plugin for this. Okay, now once you have the engines up and running, I forgot to turn on the fuel pumps. But just remember, when I turn on the electric pumps, the fuel pumps should be on. That's why this engine was not running, as you can see. Good thing that I just realized at this moment. My apologies for this. So now the fuel pumps are also up and running. So you can see this engine will also start. I can press legs over here and get these options. Now you can see it says running. So you have both engines coming running, and you can turn off the APU. That's it. Now what else? You have to set the flaps. So set the flaps to position 5. I can just move this lever to 5. Now flaps set to 5, and now we have to do the flight control check. So bring up this option, flight control, if it's not up, and then you can move the yoke. First go forward. You can see now the elevators are working. Then back. And for the ailerons, left, you can see working. And the rudder, you can see everything is now working. Now you can get rid of the screen. What you have to do is this: simply press this option, ICAS. You can see 2 errors coming, whether you can have ICAS over here on this side, or the captain side, or the co-pilot. If I press this, it will go over here. Now just a little bit of introduction to you. Right now you can see this MFD, the multifunction display, which is over here. You can have anything on the left side or the right side. Right now the left is on, so whatever you click over here, it will come on the left side. Or even you can have the CDU over here. Okay, so just press CDU over here and disappear from here. And if I press navigation display, this whole screen will have the navigation display. So right now what I can do is this: I can take this ICAS over here to the first officer side. I can also press traffic over here so that these circles start coming over here for the distance. Now as the engines are now up and running, you don't need to see the oil pressure and oil temperature and everything. You don't need this information. You can press this button, engine, and you can get rid of it and only focus on the TPI, which is a turbofan power ratio, N1, and exhaust gas temperature. What else? So you can just now bring the checklist over here, and you can have the system over here if you want to have a look at it. Okay, sorry, I actually press this button. Okay, so you can get rid of it, and then make sure that the transponder is set to TARA. Just move it over here all the way to the right. And now it's time to turn on the lights. Now you have the logo light, which is at the tail. Just turn it on. Wing light, which is on the wings. Then taxi lights and runway turn off lights. Now you have see, it's such a poor pushback. Anyhow, you can see this is the light for the taxi, and you have the wing lights up and running. Okay, so if I press N, I can just go back, and runway turn off lights done, and dome lights off. If you're flying in the night, obviously you will turn it off, and that's it. Now you have to run the checklist for before takeoff. So go to checklist, and now you will see the before takeoff checklist will come. Anti-ice, we have turned it on. Recall. What is recall? Actually, you press this button, recall, to see if any error is coming, because if there are multiple errors, they will appear on different pages. So just make sure that there is no error coming. Just press recall. It's done. Flight control is done. Ground equipment, it's clear. Now as you have power coming in from the engines, you do need the APU. You have turned it off, so APU is done. Normal. And now you have before takeoff, you have set the flaps, press normal, or even you can go over here and before takeoff. Now there is a checklist after the takeoff, which will be automatically done. Okay, so just hide this by pressing navigation display, and you're all set. Just zoom in a bit, and that's it. Now get the heads up display. Click over here and you will have the heads up display. Now you can adjust your view by pressing up and down, and plus if you keep on pressing Alt and you move forward, you will have a good view of the heads up display. So what you can do is this: you can just simply adjust the view in the middle like this. You can just go far a bit. Okay. Now some introduction of the heads up display. You have the speed coming over here, and this is the FMA, which is the flight mode enunciator, TOGA, which is takeoff and go around, LNAV and VNAV. So TOGA is active, and plus this is your altitude, and this is your atmospheric pressure, the heading towards which you will be flying or you're moving, and this is your, what you can say, the airplane indicator. Now everything is good. I can the lights are on. We've done everything. I'm just making sure nothing is left. So now I can release the parking brakes and just start the taxi. Move the TPR, give a throttle till 8. I keep it at 8 because it's a good speed at which you can taxi. Yeah, you can just keep it at over here and you can start the taxi. This is something good in the Boeing 787 that you can see the taxiways. So you know where you're going. The taxiing is easy. Otherwise, if you're using the Navigraph charts, you can also see it in Navigraph. So the flight director is on, LNAV and VNAV is also active. At times I've done flights without activating LNAV and VNAV and it becomes lots of trouble. I can get rid of this option because I don't need it. Okay, now I can see the taxiways. Interestingly, it's raining right now in Riyadh. There was a very little hailstorm, I think lasted for 3 to 4 minutes. But right now for this video, I've just kept the weather clear. Okay, so I have to turn left now. I don't know. There is this issue with this plane, or what. Even just you can let me know if you also experience this. Every time when you're texting, it pulls towards the left a lot. Even during the takeoff, it's a bit difficult. So I think the flying physics of this plane has to be adjusted a little bit, because it just pulls a lot towards the left side, and especially during the takeoff when you're just like you've pressed your rudder all the way to the left during the takeoff, the balance is also not really good. So if you find any issue in my takeoff, kindly excuse me for that, because I've been trying a lot. I've recently purchased this Airbus controller from Thrustmaster, and it's a good controller. When I fly Airbus, it works really well. The Phoenix or any other plane, even what you can say, the fly-by-wire Airbus A320 or the default Airbus A320, it works well. It doesn't pull so much towards the left, but this plane pulls a lot. As you can see, if I've just left the controller and it keeps on going left. You can see it's slightly moving. You can see. Okay. So one thing before the takeoff, I just want to let you know that you have to keep an eye over here on your speed indicator. You are seeing this option V1, which is 145 knots. So it will come, then VR will come, then V2 will come, and plus it will also tell you the speeds at which you can retract the flaps. So right now, as I've selected VNAV, the speed will be automatically selected by the autopilot, and with LNAV, it will tell the plane whether to go left or right. So there is some more ground to cover for the taxi. I will also be doing a video for the RNAV approach for this plane, and how to perform a missed approach. So do subscribe to my channel so that you can just keep on getting the updates. So here is the runway 33, right? I've been taking off a lot from this runway. It's been 10 years I'm in Riyadh. So now this city is like my second home. I spend a good time of my life over here. Now just apply brakes and engage the parking brakes. A few things that you have to do right now. You have to turn on the strobe. Strobe is actually a blinking light which helps other planes see your plane in the night and plus in the morning as well. You need these lights in the morning also because these lights are really bright, so the planes from the distance can also see it. The landing lights have to be turned on as well. I have talked to a few of the pilots. They say these lights are required because the lights are so bright that any other plane which is coming for the landing or at a distance can see your plane easily. So right now, as you can see, everything is clear. I can proceed with the takeoff. I can adjust the view so that I can just see it over here. I can keep the range to 10. It's a comfortable view. Now, what I'm going to do is this. I'm going to release the parking brakes and then move to the runway. For this, I will actually take off. I will initially give power to the plane and I will keep the TPR at 20. And once the engines spool up, then I will press this button on the throttle. This button, which is for the toga, take off and go around. And this will actually automatically set the throttle. You don't have to move the throttle on your controller. Although I've configured this button on my controller, but just to show you guys, I will be using this option right now. So once the TPR reaches 20 and the engines spool up, then I will press this button. So it's a rolling takeoff. So let's give power to the engines. TPR to 20. That's it. And let's press this button. Now you can see the throttle has automatically moved. So now the throttle will be set as per the takeoff performance. After 65 knots, you will see a toga reference line. You cannot go more than this. This is your airplane indicator. Don't let this line go more than this takeoff or indicator or toga reference, because then you will have a tail strike. You can see it gets very difficult to actually keep this plane straight on the runway. Pulls a lot. Okay, so V1 is coming. Oops. This was a good incident. V1 and now rotate. So gently pull back on the yoke. And see, I told you before, even on the takeoff, it gets very difficult to control it. Okay, so as we have a positive rate of climb, I can get the gears up. Now I'm just going to show you one more thing. This is this circle, as you can see, the small circle is actually the flight director guidance cue. So this actually tells you the flight path and plus your climb rate, and this is your flight path vector symbol. So always try to keep your flight path vector symbol, this one, to follow the flight director guidance cue. So it keeps on adjusting. Actually, it shows you the path, whether to go left or right, and plus how to adjust your climb in order to control the speed. As you can see now, the speed is increasing, so the climb rate is decreasing so that the plane can have power. As you can see now, it's crossed 5. I can track the flaps. Now I'm following this. Just make sure that this small circle, your flight director guidance cue, is in the flight path vector symbol, the bigger one. And now it has also crossed the speed 1. I can fully retract the flaps. So gears are up. And with this, I can activate the autopilot and let the autopilot do all the flying. And now you can see it will actually follow this. So this is a good indication. And now you can see as the speed is increasing, so that's why the climb rate will increase, so that the speed decreases with the given throttle settings. So now you can see it's a very aggressive climb rate. and this flight path vector symbol is trying to actually follow the flight director guidance cue. Now it's in the middle, so throughout the flight this will remain in the middle, and now you can see the speed is set to 250. So hopefully the plane will actually follow the constraint as we have seen it before over there. Otherwise, what you can do is this: you can also adjust the speed yourself, but I'm not going to touch it right now. So everything is good now. Soon plane will be crossing 10,000 feet. I can also bring up the checklist after takeoff, and let's see. Everything is done. So landing gears are up and flaps are also up, and that's it. You can get rid of the checklist, and you can see now the plane is following the flight plan. Now, as the plane has crossed 10,000, you can always turn off the lights, the landing lights. Just make sure the strobe is on, and the nav and the beacon lights. Rest, you have to turn off all the lights. And during the approach, once the plane is below 10,000, you have to turn on all the lights back up again. Now you can see the speed is set to now 307, as I have entered a high value. That was 100 for the cost index. That's why plane is going at a high speed. But as we have seen it before in the SID, if I bring it up, now there is a speed constraint 250. You can always restrict it. Just press this button and just reduce the speed to 250. You can also do this. If you see that the VNAV is not following the speed, you can always reduce it. Right now you can see it's an aggressive climb, so that with the given thrust power, the speed reduces, and as soon as the plane is at 250 knots of speed, the vertical speed will decrease in order to maintain it. And now you can see, because the steeper the climb, the speed is compromised. So that's why right now VNAV speed, you can see it's coming. The preference is given to the speed, so the vertical speed is adjusted in such a way that the plane keeps on following the given speed. So you can also adjust the speed like this, and after this point you can maybe increase it to 307, or you can just press it once again in order to follow the speed which is calculated by the VNAV. And if I take you over here on the legs option, you will also see the speeds and different altitudes coming at different points. And even over here, as you can see, at this point 7,000 and above, and yes, 7,000 and above. And as I've crossed the transition altitude, I press this button and you can see standard atmospheric pressure is coming. So transition altitude is an altitude at which you actually change the barometric pressure from the given one to the standard. So that's it. I am not going to be showing you how to fly in the heading mode. Maybe I make another video for this, but right now for this video, I'm just trying to keep things short and simple, because I cannot cramp up all the information in just with one video and just bombard you with different options. But just for this video, just let you know that you can use LNAV and VNAV to do a successful flight. The plane will actually go to 38,000 feet. As you can see, top of climb is coming over here, and at this point the plane will be at 38,000 feet, and this is the top of descent. As you can see, from this point I will start the descent. So after the top of climb, I will then take you through the descent procedures, and will tell you how to prepare the plane for the approach and for the landing. Now, as you can see, the plane is cruising at 38,000 feet. I can get rid of the heads-up display. I don't need it anymore. Nice layer of clouds. It's cloudy today. Okay, so as you can see, there's some little distance to cover to the top of descent. So before this, we have to do some settings for the approach. First of all, let's get the Navigraph charts. And you have to actually set the heading. So for the landing, you can see the heading for the runway at which we're going to land is 31 left, and the heading is 306 degrees, so you have to enter the heading over here, 306. Now as the heading is set, I would just like to tell you why we are setting this heading, because in case of a misapproach and you don't activate the LNAV, because LNAV and VNAV will be deactivated during the landing. So if you decide to abort the landing, then you will flying in the heading mode. I will not be using this option, but anyhow, just to tell you how to prepare for the landing, you will be setting the heading. And plus, initially, if you remember in the video, I told you that if you get vectors for the landing, then obviously you will be automatically adjusting the heading as per the ATC instructions or as per the flight plan. But as now we're going to fly the complete flight path using the LNAV, so that's why we don't have to adjust the heading near the runway. So we can do it right now and set it to 306. Now go to the CDU and go over here, index and approach. Now we have to enter some approach settings. As you can see that different flaps settings are coming for the landing. You can also land with 20 degrees of flaps, and the speed will be 152 knots. With 25 degrees of flaps, 151 knots, and with full flaps, 147 knots. I will be landing with full flaps. But before this, we have to set the gross weight. Right now, the gross weight of the plane is coming whatever it is right now, but obviously till the time we reach the runway, we will be burning some fuel. The current fuel is 9.0, and if you look at this option, progress 6.4. So you will be burning 2.6 kgs of fuel. So all you have to do is this subtract 181, 2.6 from 181.1, 181.1 minus 2.6, and this will be 178.5. So this will be a gross weight. There will be some changes in the reference. So let's enter this weight. Let's get rid of the yoke, 178.5. And you can see there was some little changes in the speed. So you can select this option, and then you can just enter it over here. So you can land with full flaps, and your speed will be 145 knots for the landing. Now another thing, to which altitude you should be descending. If you look at this approach plate, it has got lots of information in it. Let me just get rid of all the things and so that I can see it clearly. This is basically the approach plate, and it has got so much information on it. As a beginner, you can just open any tutorial and try to learn more things about this approach plate. But right now, I will be just taking you through the basics. As you can see, this is the glide slope, and the angle is 3 degrees. And you will be at D 9.2, which is DMA 9.2 miles, or distance measuring equipment 9.2. You will, at this point, you will fly in the heading of 306, and you will take an angle of 3 degrees, and you will descend to the runway. The runway height is 83 feet above the sea level. Mandatory 3000. In order to intercept the glide slope, in order to perform a proper ILS at Lubeck at this point, your altitude should be 3000. If you're below it, obviously you will be still able to make it, and if you're above it, then it's an issue, because then you have to have a steeper angle of descent, which might lead towards increased speed, and you might miss the approach. But if you're coming even at 2000, you can still catch the glide slope at some point, but it's good to be at 3000 feet over here. So for the descent, what I'll do is this. I will set the altitude to 3000. I'm doing it right now. Nothing will happen because the plane will start to descend if I press this button. Now you can see this hand option coming. If I press it now, then the plane will start the descent. But if I set the altitude right now, as soon as the plane has crossed top of descent, it will automatically start the descent, and it will go to 3000 feet. As you can see, end of descent, it's coming over here. So just right before the runway, the plane will be at 3000 feet, and then you can follow the glide slope. That's it. And plus, these are the minimums coming for the ILS, category 3B ILS, 3A, 2A. to ILS, and you're getting some information over here. I can even set it to 50 feet decision height, but I will use this option, the category 2, to be on the safer side. What is the minimum altitude? It is actually an altitude at which you will hear the sound minimums from the cockpit. It actually depends upon the ILS equipment a plane has. The more accurate the equipment is, the pilots can rely on the ILS approach, and just at this altitude, when you hear minimums, you will just see the runway. If the plane is properly aligned with the runway, if you are going to touch runway at the right touch zone, then you can proceed with the landing. Otherwise, then you can abort the takeoff. Right now, you can see decision height and altitude. So it's coming. Decision altitude is 183 feet above the runway, which is actually 100 feet, because 83 feet is the elevation of the runway, so 183 feet. So you will be using the barometric pressure. RA is 94. RA is actually radio frequency which is emitted by the plane to measure the distance from the ground. It's not advisable to use it because if it's an uneven ground before the runway, you will not have right readings. So that's why I always use the barometric pressure or the standard way of calculating the altitude for the plane. So over here in the EFS, you will see this option minimums coming, either baro or radio. You can set baro or radio, but for this, we will set baro, 183 feet. So just move it to, if you move it too fast, it jumps a lot. So I'll keep it at 183 feet, which is 100 feet above the runway or 183 feet above the sea level. Okay, so that's the difference in decision altitude and height. Height is 100 and altitude is 183. It gets very difficult. The click regions are very tricky. Okay. 183. Okay, now it's done. So you have entered all the necessary information. You have set the approach reference, you have set the minimums, and if I go to the checklist and go to the descent, you will see once the descent starts, we have to recall and see if there's any error coming on the ICAS, and then you have to set the auto brake, you have to set the landing data, which we have already done, and approach briefing, it's complete. So you can get rid of this. So few more things I would just like to tell you. This is the heading of the runway, as I've told you before, and this is the ILS frequency, which is 109.3. If you go to this option, radio, nav radio, you will see as soon as the descent starts, or maybe you're near the runway, you will see the ILS information coming over here. This is the VOR right now. Bahrain VOR is coming, 111.80. As you can see, and the distance is 12. So you are moving away from Bahrain. And I think we will be flying over Qatar right now. And soon we will be in the UAE territory. Okay, so the ILS information will also start to appear over here. So you don't really have to worry about it. Just make sure it's coming. Otherwise, in this plane, it's automatically picked up. Okay. Now, on the approach plate, you will also see the missed approach procedure. Climb straight ahead to VDEX at 4,000 feet. Then turn left, maximum speed 210 knots to VTOC and hold. Climb to 4,000 feet. So once you miss the approach, you go and land, and then over here you can see the missed approach coming. So you'll keep on flying in the heading of 306 degrees. And even if you look at this navigation display, you will see the missed approach procedure is coming. So maybe you can fly based on the heading, or you can activate LNAV and the plane will automatically then follow the missed approach procedure. I will be making another video in which I will tell you how to perform the missed approach. That's it. And then the minimums option is coming, as it's saying. You can refer to the minimums over here. We have already set the localizer frequency or the ILS frequencies 109.3, approach course 306 degrees, and then you have your tower coming north and south, the frequencies. If you're using VATSIM, then obviously you will be tuning in different frequencies as per the VATSIM, and that's it. So as a beginner, right now, this is, I think, more than enough for you for the approach plate, and then you can further watch any videos regarding the approach plate. Actually, I haven't done any video on the approach plate, but maybe in the future I'll do some videos so that you can easily read the approach plates and see how to perform a good approach. So I'm back. So now let's wait for the top of descent to come, because at this point the plane will automatically start to descend. You can see as I've turned this traffic option on, so now you can see it's almost 80 or less than 80 nautical miles away. And this is actually an increment of, you can see 160, now it's 40. So it's 20 and then it's 80. Sorry, 60. It's an increment of 20. And if you have 80, then it's an increment of 40s. Okay, so that's how it is. Soon it will be 60 nautical miles away, the top of descent. If I go to progress, I think you can also see it over here to top of descent, 74 nautical miles, as you can see. Over here it will be 60. And the time is also coming, 9:27 in the morning, Zulu. It's 9:17. In the next 10 minutes, we will be there. So if you're wondering that how the pilots tell you the exact time for the landing, so this is how they do it, because of with the help of the CDU, because time and distance calculation is there. Now, as you can see, that the top of descent is near, and soon the descent will start. As I've set the altitude to 3,000 feet, so the plane will start to descend to 3,000 feet. What I'm going to do is this, that I'm going to consult the page legs and see the speed during the descent. It's 250. It's very less. So what I'm going to do is this. I'm going to set the speed myself. So I will select this option mark. As above 30,000 feet, the air is thin. So that's why the speed is measured in Mach instead of knots. So the speed will actually adjust to 0.79 Machs during the descent. And below 30,000, then I can set it to knots. Right now you can see it's already coming at 250, but it will keep on increasing as the plane starts to descend. I can even keep it over here, but I will try to descend at 280 knots. So maybe we can just increase it and override the speed. Now with this, what we can do is this. We can even turn the seatbelt signs to on, but I will leave it to auto. As soon as I will extend the flaps or the plane is below 10,000 feet, the seatbelt signs will turn on. You will hear a chime in the cockpit. Now the descent should start anytime. As soon as the plane crosses the top of descent, and then you will see the vertical deviation over here as well. And now you can see this vertical deviation started to appear over here on the primary flight display. And this triangle is your indicator that is the plane following the descent profile or not. Now as the speed has been set to 0.8 Mach, you will see that the speed will keep on increasing. So I will try to keep it at 280 by adjusting the speed in Mach. Although it's coming as 250, it's very slow. It will take a lot of time for the plane to reach the runway, so that's why I've kept a higher speed. But over here, there are a few constraints that the plane has to follow at Ukili. The plane should be 15,000 below, and the speed should be 250 knots. So at this point, I have to change the speed to 250. Okay, so as you can see now, the speed is increasing. It's 284, so I can reduce it, and I can keep it over here at 0.83 mark. Now let's consult the standard terminal arrival page, the star, and as you can see at Ukili, a maximum speed 250, should be less or 250, and the flight level should be below 15,000 feet or 15,000 feet. As you can see, there's a line coming over here. So I will keep this chart open so that we can refer to the chart as well for the star. Now there's an error coming as unable to maintain the VNAV descent speed. The speed is not reducing. So you can ignore this. The speed is not really high, or maybe you can extend the brakes, speed brakes a little bit so that the speed decreases. And just keep an eye on the vertical deviation. If this triangle goes up, it means you are below the descent profile, which is okay. But if this triangle is below, it means you're coming at a higher altitude. You're above the descent profile, which is something to be really worried about. As now the speed is in control, I can deactivate the speed brake. And as soon as the plane is below 30,000 feet, this should change to knots. Now the plane is following the speed and following the descent profile, which is good. If I go to the NavRad page, you can see the ILS approach information is coming. The heading 306 degrees, which I have entered over here. This is the heading of the runway. Now you can see it has changed to knots, 280, so I will keep it at 280. One more thing I would like to tell you is this, that you have to refer to this side of the cockpit, which tells you different speeds at which you can have flaps. At 260 knots, you can have flaps for 1 degrees, and so on and so forth. And different speeds, the different flap settings are coming. So as soon as I'm below 260 knots, I will start extending the flaps. Right now you can see the speed is slightly increasing, but this is the threshold within which the plane can descend, because right now the priority is given to the descent, because the plane has to follow the descent profile. If you try to adjust the speed by adjusting the vertical speed, there are chances that you might miss the descent profile, so you don't want this to happen. So some more distance to cover, and at Ukili 15,000 and below the plane will be, and soon the transition altitude will also come. Now let's go to the checklist, and let's go to this descent checklist recall. Now you have to press this button recall in order to see if any error is appearing over here in the ICAS. And you can see recall comes. When recall comes, it means when recall comes, it means you have scrolled through all the pages, and you can see there is no error coming. So there is no error. Yeah, let's bring the checklist back again. And auto brake, you have to set it to max, or you can get any setting. Actually, this is done using the landing performance calculator, which is also a part of the electronic flight bag, just like you calculate the takeoff performance. So for the landing performance, you actually enter the length of the runway and the condition of the runway, and plus the weight of the plane, in order to see that how much auto brake is required to stop the plane on the runway. But right now for this video, I will use max because we don't have a landing performance calculator. Landing data we have already entered. We have entered the minimums, and plus we have also adjusted the full flaps speed, which is 145. As you can see, with 30 flaps, 145. Reference speed is coming. And approach briefing is also complete, normal. And for the approach, we have to adjust the altimeters. As soon as the plane is below 18,000 feet, you have to adjust the altimeters, change it from standard to the given one. For Abu Dhabi, it's 1008 QNH, so I will adjust it to 1008. You can get this information from the operational flight plan, from the weather list. And at this point, I will reduce the speed to 250. So let's open this chart. and see how far we are. So not so far, so I will reduce it because I don't want to engage the speed brakes and see if the speed still reduces, because the plane is now adjusting the vertical speed. It's still following the glide slope or the flight descent profile, not the glide slope. So that's why everything is okay. So now the speed is reducing. You can just let it be like this, or if you find that before this point the speed is not 250 knots, then you can apply speed brakes. You can keep the checklist over here so that you ensure that nothing is missed. By this point, the plane should be below 15,000 feet, right now 21,500. Below 260 knots, I will start extending the flaps, because then the flaps will also provide drag, help me reduce the speed, and plus provide an additional lift at the slow speeds. So flaps are required. You get this error, drag error, because it's not actually, plane is not reducing the speed. So it's okay. We have some little more ground to cover. Can I have the heads-up display? Yes, okay. Let's get the heads-up display over here. Now you can see this -3 is coming. This is actually your reference line for the glide slope, -3 degrees. So, it's a good descent profile. It's actually following it. As you can see, your flight path vector symbol, it's just on this line, 270. Which is okay. So that's why I was telling you that it's good to have the Navigraph chart subscription, because then you can see all the speed and altitude constraints over here, although they're also coming over here. If you don't want to consult the airport charts, you don't want to have the subscription, then you can refer to this page. .266 knots. The speed is reducing, so I'm not really worried. And now soon I have to change it to 1008. Now it's adjusted. You can just check this item in the checklist. And now for the landing, speed brakes armed. So I can arm the speed brakes right now. Yes, now the speed is below 260, so I can extend the flaps to position 1. Now as you can see, the flaps are providing a drag, so that now the speed has drastically reduced to 250. Sudden decrease. I can arm the speed brakes. Speed brakes are actually required at the landing as well, because as soon as you'll activate the reverse thrust, it just kept out of my mind. You activate the reverse thrust, the speed brakes are also activated, which helps the plane to stop after the landing. So now, as soon as I will lower the gears, and I will set the flaps for the landing, these items will also be checked, but I will keep this list over here, the checklist, in order to ensure that I'm following the procedures. And plus you can see over here in the ICAS, the speed brakes are armed, the auto brakes are set to max, so everything is good so far. All we have to do is this, just manage the descent and just keep an eye that everything is good. By this point, the speed should be 230 knots. The plane will be below 9,000 feet and above 7,000 feet. There's also a ceiling of 9,000, and you cannot go below 7,000. So between these two altitudes, between 9 and 7. Let me just adjust the view in the heads-up display. Yep. Now it's set. It's good. Now the plane is at 15,000 feet, and I think it will not further descend. A 530, 11,000 and above. I think it will start to descend soon. Let's see. Now you can see the ILS or the localizer's name is coming, IAW, and the heading 306, which I've entered over here. It will be required in case of a missed approach. As you can see over here, this up is coming. It means you can, up to this speed, you can fly with no flaps, but below the speed you have to have flaps. But right now I have just extended the flaps because, as I've told you before, they're providing a drag. So it's helping me control the speed during the descent. I don't have to use the speed brakes. Now soon the plane will be going below 10,000 feet. So I can now turn on the lights for the landing. And you will also hear a chime for the seat belts. So now I can reduce the speed to 230 knots. Now the speed is reducing at a higher rate because I now have the flaps. I can further extend the flaps. This is the maximum speed limit for the flaps, this red and black dash line. So now you can hear the seatbelt signs are on as I've extended the flaps to 5. The seatbelt signs are now on. Otherwise, they would have turned on below 10,000 feet because I've set them to auto. And now with this, I can turn on the logo light, the wing lights, and the landing lights. Because as I've told you before, all these lights are required because, the lights are very bright. So from the distance, the planes can see you, especially if you're landing and any plane is waiting for the clearance for the takeoff. It can see your plane clearly because, the lights, they shine very bright in the morning as well. So now the speed is at 230 knots. The flaps are set to 5. So till this point, ITRIN, I can fly at the speed of 230. Then I can over here go to 210. After TAPTO, nothing is coming because then the rest of the information is in the approach plate. As you can see, ITRIN, the speed is coming, maximum 210 knots and altitude 5,000. Let's go back and let's keep an eye on the flight. This is now the distance coming from the runway as I am near the airport flying from here. That's why this distance is reducing, and then as soon as I'll cross it, it will keep on increasing unless I am in the final approach over here. This distance will keep on increasing, otherwise it will decrease as soon as I'm near the runway. $230, which is like good. So after TAPTO, I can reduce the speed to 210 knots and I can further extend the flaps. You can see I can extend the flaps to 20, which is like good. At TAPTO, altitude should be 7,087. Soon the plane will also descend. Now you can see the IRS indicators have also started to appear on the primary flight display or on the heads-up display as well. As you can see, these diamonds, it should be in the middle in order to catch the glide slope by this point. Lubic, it will be in the middle to follow the glide slope. And as soon as the plane has turned left turn over here, I will also activate the approach, and the plane will automatically now then follow the flight path and the glide slope. Now the descent will start soon. And if it doesn't, then you can use vertical speed to reduce the altitude. This plane is capable of landing with autopilot, which is an auto land option, as both the autopilots are active. So the plane will actually auto land, but I will only disengage the autopilot to take control of the plane and to steer it and to go up and down. But I will not disarm the auto throttle. I will let the autopilot adjust the throttle. But otherwise, if you want to even perform an auto land, just keep on waiting for the plane to touch the runway, and then you can extend the reverse thrust as soon as the plane touches the runway. Now the descent has started again. As you can see over here, the vertical deviation again has started to appear, and the vertical speed is also coming. So after TAPTO, I can set the speed to 210 knots. During the landing, once you take control, just make sure that this flight director guidance is in the middle of the flight path vector symbol, just like this, as it's appearing right now. So you just have to center this smaller circle in the bigger one. Now I can further reduce the speed to 210. And with 210, let's keep it over here, and I can now start extending the flaps to provide a drag. And you can see now, as soon as the flaps are extending, the speed is also reducing. Do not extend the flaps more than 20, because then you will hear an error. Landing gear, because after 20 degrees, if you extend the flaps, it means you're going for a landing. And if the landing gears are not down, then it's an issue. You'll hear this error. So it's a safety procedure. I can keep it at 20, as you can see, just at the speed limit. And Emosu, at this point, I can reduce the speed to 150. Now you can see that the ILS diamond has now started to go up. It means you're lower than the descent profile. So eventually, as soon as you are at Lubeck, this will actually come down. And as soon as the plane is aligned with the runway, with this path, I can also activate approach. And once I activate the approach, the plane will automatically actually start to follow the glide slope. And plus, it will also align itself with the runway. Let's keep it at 200 because a little bit of change in the speed is giving me the speed errors. So let the plane get itself aligned with the runway, and then I can activate approach. 4,000 feet, 1,000 more to go. I can just get rid of this. Now it's about to level off in the next 700 feet. You can see the still diamond is up, but I think at Lubeck it will come in the middle. So this is the approach button. As soon as you press it, then the plane will actually start to follow the glide slope and align itself with the runway. Can I do that? Okay. Now the plane has leveled off at 3,000 feet. Now I can wait for this diamond to come in the middle and activate approach, or maybe I can just do it right now. The plane will actually not descend right now. As you can see now, the LNAV has disappeared. Now the plane will slightly do some adjustments in order to align itself with the runway. And plus we'll wait for this diamond to come in the middle, and then the plane will follow the glide slope. I can now further reduce the speed to 180 knots. And now you can see this diamond is moving in the middle. If it was below, then obviously it was an issue. But as it's above, no need to worry about it. You're coming at a good altitude, you will be able to land. 10.6 DME, which means distance from the runway, nautical miles. And at 6 DME, I will lower the gears and get the full flaps. .2, I can further reduce the speed, keep it at 150. This is the reference speed for the approach, or the approach speed, 7.4. Now you can see the plane is actually following the glide slope, as VNAV and LNAV are both deactivated, and now this approach button is actually taken control. 6.7. Now 5.8 DME. Lower the gears. Wait for the gears to be deployed, and then full flaps 30, reduce the speed, keep it at reference. With this, I can disengage the autopilot by pressing this button, or pressing the button on the controller. And now I have the control. Now the auto throttle is not deactivated, so now the autopilot is adjusting the auto throttle, but I can now fly the plane left and right, up and down. And just to tell you that just follow this flight director cue, and you will be able to land. As soon as you are 30 feet above the ground, just perform a flare, pitch up the nose a bit, and bring the throttle to idle position on your controller. And then as soon as the plane touches the runway, just activate the reverse thrust. Although, as I've told you before, I could have auto-landed this plane, but for this video, I'm just trying to show you, if you want to land it yourself, how you'll do it. So just try to follow the flight director cue. Just try to make sure that the small circle is inside the larger circle or the bigger circle. And that's it. You will also see the PAPI lights, 2 white, 2 green. It means you are 2 white and 2 red, not green. So which means you are following the glide slope. You can see it, the runway. So you can see you're perfectly aligned with the runway. Soon you will hear minimums, 220 feet. At 183 you will hear minimums. Minimums, which means you can still abort the takeoff if you want, perform a go around, but otherwise I will just go with the landing. .30, pitch up a bit and throttle idle. Activate reverse thrust. Below 100 knots, just deactivate the reverse thrust. And now the auto brakes will stop the plane. As you can see, the still speed is reducing, and if I apply the brakes, further speeds will reduce, and that's it. Now I can just go off the runway. With this, I can get the flaps up. Speed brakes will be active, so deactivate them. That's it. And strobe, turn it off, because as soon as you're off the runway, you don't need strobe. And what else? Okay, now let's give some power for the taxi. Now what I can do is this. Right now I can turn on the APU, because as soon as I'm parked at the gate, I will turn off the engines, and I need some power, so that's why APU will be required. And as soon as I will connect the plane to the external power, I will also turn off the APU. With this, you can also turn off the landing lights, as you don't need them. Just keep the taxi lights on. So I can just park at this gate. If you get the gate from the ATC, then you have to go to that gate. Or otherwise, whatever the first gate I'll see, I'll just park it over there. Now you can see here the APU is also available. 100 EGT is coming, so that's it. Just bring up the checklist. Now shutdown checklist is coming. Okay, so that's it. I'm at the gate. Parking brakes, lights off. Brake lights off, logo off, and now shut down the engines. With this, you can turn off the seatbelt signs. You can let the people go. And this is, by the way, a very good sound. As soon as I hear it, it means you have reached home. Now the engines are off, and what you have to do is this. For the shutdown, you have to turn off the hydraulic systems. So what you can do is this. You can turn off the hydraulics. Automatically check fuel pumps. You have to turn off the fuel pumps. You don't need them. That's it. And connect to the external power. As soon as the external power is connected, you can turn off the APU. And the parking brake is set, and that's it. Now the last checklist is for the secure. I will just tell you how to do it. If you want to do a next flight, you can then just continue with the ground services, get the jetway connected, get the luggage and everything. And then you can go for another flight if you want. For this, I'll just tell you right now what you can do is this. If you want to do another flight, just simply click this option, checklist reset, and this whole checklist will be reset, and then you can continue with another flight. But if you want to secure the plane, just make sure that the IRS is off. So the way you got the plane, just you have to put it in the same way. So just turn off the IRS, and then you have to turn off the emergency lights. So if you go here, emergency lights, you simply, let's press Control 8 in order to interact with it. And I've told you before, these click regions are very, very... Oh, now it's off. That's it. And what else? The packs, they should be off if you're going to secure it. So the packs are off. Now, everything done. The plane is just like the way you got it. And all you have to do is this. Just disconnect the external power and turn off the battery. Oops. So now the plane is again in the back dark and cold state. You can again start it up and do another flight if you want to secure it. But if you want to do another flight, don't go with this secure procedure. Just go with the shutdown procedure and you can do another flight. With this, I would just like to end my video. Thank you very much for staying with me. Please don't forget to subscribe to my channel. Have a nice day. Hope to see you soon.